Yeah. So we have a small HBase MapReduce hands-on. So this has been developed by Li Hui. So in this hands-on, we're gonna read a CSV file using a MapReduce computation and gonna save it to a HBase table. Yep. So since we are running out of time, I'm just gonna demo it, and then the slides are available and the instructions are available online. So if you're interested in trying it later, you can just get the slides and use your VirtualBox-based VM to do this hands-on. So we're gonna first start up Hadoop. I'm running this on the image that you have in your VirtualBox. So you can do all of these things in your VirtualBox image as well. Yep. So the instructions for running this program is available in this slide. So it's pretty much self-contained. So we did the starting up Hadoop part, and now we're going to start HBase. So it's already configured for you in your virtual machine. And as the next task, we're going to log into the HBase shell and going to create a simple table. So this shell supports commands like scan, which will output the data stored in a table, as well as commands like list, which will list the tables that are stored in HBase, and create, which will create a table in HBase. Oops. I'm sorry, I didn't input the column family. So when creating tables, we need to input the set of column families we're going to use in the table. So in this case, the table name is the CSV to HBase table, and the column family is the F1. So we're going to use just a single column family. And now I'm going to go back to the HBase tutorial and copy the data to the Hadoop distributed file system. And then I'm going to execute the MapReduce computation. So I create a folder in Hadoop distributed file system called input. And now I'm going to copy a sample data file to that to the folder we created. So we can use the Hadoop DFS ls command to see whether the file is correctly copied. Yeah, it's there. So now we're going to run our Hadoop MapReduce computation. So now we are running the computation on the data we copied, and this MapReduce computation will read the data from the DFS and then input it to the HBase table we created. So actually, I mean, we are doing this as a demo to show that HBase and Hadoop can work together. But then HBase comes with the inbuilt tool called import TSV, which you can use to import any character delimited data into HBase table. So it can be tab delimited or CSV delimited. You can use this import TSV tool to import it to HBase table. I'm not really sure what's going on the reduce task. Maybe the VM is having some issues, but I'm not going to investigate now because we already ran out of time. So yeah, so after this computation is done, we can log back into the HBase shell and then do a scan and then give the table name, and then there you will see the records that are imported to HBase. So you can see that in this slide where we do the scan and then you have the data values. So that's a very simple sample data set. So what are the other features of HBase? So it supports bulk loading of data. So HBase has the table output format to write data to the HBase tables from the reduced task of MapReduce computation, but then that can be slow because you are going through the APIs. But then you have this bulk loading method where if you use the H-file output format, it will directly write a native file in the format of HBase as the output of your MapReduce computation, and then you can simply import it to HBase. So then there won't be any conversions or any, I mean, it's like you are simply dumping the data to the native format of HBase and then import it to the HBase. And then you can have multiple masters in case of as a failover mechanism. And then you can also define in-memory column families. So whatever the data that's in memory column families would be persistent in the disk as well. But when you have them in memory, you will get much better performance. And then HBase also supports a block cache. So it's a caching mechanism for blocks that are stored in HDFS, as well as a feature called Bloom filters, which is a client-side caching mechanism, which will improve your data access performance. So in the next session, we have introduction to Pig Latin from Hui. And then at the end of that session, there will be a demo where we'll be demonstrating a search engine system developed with MapReduce technologies. So the search engine system will use Hadoop, HDFS, HBase, Pig, and all of these things. So that will be a good example how to integrate all these things together. Thank you. Any questions?
Could you tell me some usefully as a question? Apache Cassandra and HBase?
So the question is, what is the difference between Apache Cassandra and the HBase? So first of all, HBase favors consistency over availability. I mean, it's not that it's not available. It's fairly, it provides good availability, but it doesn't guarantee availability. But when you look at Apache Cassandra, you can configure your consistency and the availability. I mean, you can have either consistency or you can have either availability. But most of the time, people use Cassandra with eventual consistent mode, where you get availability but not the data consistency. So in terms of HBase, it's always you have the consistency, but you might lose some of the availability. So another change would be HBase is column family-based storage, while Cassandra is a key value-based storage. Yeah, so so another thing is this native integration with Hadoop, which is much better with HBase. And one more, yeah, actually, yeah. So the HBase also supports ordered range partitions of your data. So if you want to do MapReduce computation with a certain range, you can do those things. And if you want to do a query with the range, so that range is sorted and you can access it. I don't know for sure whether Cassandra supports that or not, but that's a feature of HBase. So that's all the information I have. Thanks.